Greetings. My name is Joseph Kendall-Morwick. I'm an assistant professor of computer science in the Department of Computer Science, Math, and Physics in the School of Science and Health at Missouri Western State University. I'll be talking about the scholarly impact and potential of open source software development. Beyond being a model for software development, free and open source software, or FOSS, development is having a cultural impact on the commercial software industry. FOSS is also having a cultural impact on academia, particularly in computer science. Although FOSS has seen many successes, such as the Linux operating system, it has not made considerable headway into the many domains where private cloud-based software dominates, such as social media, citizenship, healthcare, transportation, communication, and many others. University collaborations in FOSS development, whether through research projects or applied learning projects, have the potential to bring universities' problem-solving capacity to bear on problems faced by their communities and better realize the ultimate goals of scholarship within academia. This presentation will expose the scholarly nature of FOSS contributions currently developed by both students and faculty at universities worldwide. It will identify the alignment of goals of FOSS with those of universities involved in research and applied learning. Finally, it will make the case for the scholarly value FOSS development at universities has and identify future avenues for this work to enhance the university's civic and societal impact. Definitions of scholarly activity can vary from discipline to discipline, but a common thread in such definitions is peer review and public availability. Originality is also emphasized, and in the sciences especially, reproducibility is quite important. Artifacts of scholarly activities can also vary, but again, there is a common recognition for published journal articles and books that meets the above criteria. In the influential book, Scholarship Reconsidered: Priorities of the Professoriate, Boyer identifies multiple categories of scholarship: discovery, integration, application, and teaching, and identifies discovery as the primary category for traditional research over much of the latter half of the last century. This category makes the traditional peer-reviewed article an ideal means of documenting and communicating such advances. However, other media, such as software, present an opportunity and even a motivation to move further into the other areas of scholarship. The interpretation of what is scholarship can and should be informed by the mission of the university. Surely the goals of scholarly activities are. For the purposes of this paper, this brings particular focus to universities such as Missouri Western, whose mission focuses on applied learning and prizes close interaction with students, especially undergraduates. In the same book, Boyer also writes that, quote, "We need a climate in which colleges and universities are less imitative, taking pride in their uniqueness. It's time to end the suffocating practice in which colleges and universities measure themselves far too frequently by external status rather than by values determined by their own distinctive mission," end quote. Boyer further indicates that education at these institutions will be improved, quote, "in large measure by the way scholarship is determined and ultimately rewarded," end quote. Although I believe many universities will benefit from expanding the traditional notion of scholarship to include FOSS development, universities such as Missouri Western may find even greater benefit. Free and open source software as a set of principles arguably began with the GNU project in the 1980s, a project to develop a free operating system similar to a proprietary Unix operating system. This project was accompanied by the development of the GNU General Public License, known as the GPL, the first software license to require what the Free Software Foundation calls the 4 essential freedoms, which are the freedom to run the program as you wish for any purpose, the freedom to study how the program works and change it so that it does your computing as you wish, the freedom to redistribute copies so that you can help others, and the freedom to distribute copies of your own modified versions of the software to others. Many FOSS licenses adhering to these principles have followed. Perhaps the most well-known success of FOSS is the Linux operating system. Linux, in part, came out of the GNU project. In particular, the GNU utilities comprised much of the application supporting the operating system kernel, which was part of a developer's effort begun by Linus Torvalds while he was a student at the University of Helsinki. Linux was largely developed by a loosely banded worldwide group of volunteer developers and a massive open effort made possible by the internet. Today, Linux powers most of the web servers on the internet and the Linux kernel is the backbone for the most popular mobile operating system, Android. The free and open nature of Linux has led to countless opportunities for study and development unencumbered by restrictive proprietary software licenses, and has undoubtedly shaped the culture surrounding software development, where the open source format is very popular even among for-profit corporations. In Hafer and Kirkpatrick's 2009 article assessing the scholarly value of open source software, they begin by stating that, quote, publishing papers about software is considered a distinctly stronger contribution than publishing software, end quote. 2009 was about the time I started publishing papers myself, and in my own research and personal experience, I can attest that this is still true. A non-exhaustive search through the faculty tenure and promotion handbooks of dozens of universities yielded only 2 that are explicitly mention open source software, Belmont University and our own Missouri Western. In the former case, open source software is explicitly identified as a secondary or scholarship 2 contribution below peer-reviewed publications. Hafer and Kirkpatrick classify FOSS development as being primarily in the scholarship categories of integration, application, and teaching, rather than discovery. Whether or not this is the reason for its recognition as secondary scholarship, it's important to closely analyze its relationship to more traditional first-tier activities. Missouri Western indicates that it can be a first-class artifact, but provides only vague guidance on the requirements for peer review. I'll look deeper into both of these issues in the next section. FOSS development and academic publications have their differences, but they also share a lot in common, especially in the ways that academic publications meet the standards for scholarly work. Like a paper, software is and should be recognized as a transfer of useful knowledge, although the domain of that knowledge is much more tightly constrained to simple processes and the peculiarities of formal languages and the interfaces with which they operate. Free and open source implies a standard for public availability beyond what many academic publishers provide. The reproducibility of source code is practically absolute, well exceeding the capacity of a paper to describe an experiment to a reproducible extent. While originality is not a cornerstone of FOSS development, proper attribution of sources is, particularly through the use of open source software licenses and the ability to track the development of a project through version control. One potentially important difference is that software can be seen as rather impermanent, given the shifting need for the software, definitions of programming languages, and availability of protocols and interfaces. This may affect how the impact of a FOSS contribution is considered. However, limited life and usefulness is not unique to software. Especially in a relatively young field like computer science, publications can also lose their relevance and impact rather quickly. Both types of artifacts live on, however, through their influence on future work. One area where it's difficult to draw a clear analogy between publications and FOSS development is peer review. Although processes for such review exist in FOSS development, they can be difficult to formalize and lack clear metrics for a number of reasons. First, it isn't clear what a peer is in this context. Small contributions can be judged by developers maintaining the project by whether they accept these changes or not. However, it's hard to say that this is clearly independent review, given that in smaller projects the relationship between maintainers and developers is very close. In many cases, the developers seeking credit for their work are the project maintainers themselves. Secondly, it isn't clear what the significance or impact of a contribution might be. Important contributions can be a very small part of a very large project, and other contributions might be as large as the project itself. How is the breadth of contribution quantified? Lines of code may not always be a useful measure. A few print statements aren't nearly as meaningful as a clever recursive call. And what about later changes to a project that overwrite a contributor's changes? Does that mean that the contributor was written out of the project, or does their contribution still exist? Beyond credit within a project, it's also unclear how to award credit outside of a project. Only some software projects are intended to be used as components in other software projects, which is the clearest analog to citation. Adoption and usage could be considered somewhat equivalent to citation, but measuring this is difficult and not always indicative of the importance of the software. Social media endorsements, such as the star option on GitHub, could be considered part of a metric. However, these types of endorsements are of dubious quality when compared to peer review and are easily manipulated. It seems that FOSS development itself is worthy of being considered scholarship, but measuring the impact of that work remains a challenge. Hafer and Kirkpatrick present a set of best practices for recognizing the impact of FOSS contributions, but more meta-level research is needed to drive the academic community closer to a consensus on such standards. To be fair, like the issue of lifespan, these challenges in evaluating the impact of artifacts aren't unique to FOSS. Peer-reviewed publication is also vulnerable to abuses and can similarly result in work of little importance, as outlined by Denning in A New Social Contract for Research. The judgment of tenure and promotion review committees is still relied on heavily in these cases as well. It's also worth considering that the efforts to legitimize FOSS contributions as scholarly may also improve the way we judge more traditional academic contributions. One step towards judging the impact of the open source work might be to separately judge the importance of the contribution from the importance of the project itself. For example, GitHub pull requests are a useful way to capture a single, coherent contribution and to facilitate review. They represent a small contribution, but one that is large enough to satisfy some requirement of the overall project. A formula involving evaluative criteria, such as those considered by Hafer and Kirkpatrick, for the contribution, and separately for the overall project, and a peer review process of independent FOSS-savvy scholars, similar to what Ambati and Kishore describe in their paper, How Can Academic Software Research and Open Source Software Development Help Each Other, could be a further step towards a means of properly evaluating these contributions. A successful software product or service often looks a lot like public infrastructure, at least in the sense that public infrastructure is developed in part to support commerce. Consider some of the more successful software projects that became companies. Perhaps the best example of a dot-com success is Google, now Alphabet, which came to prominence following the development of the Google search engine, a tool that matches a user with content. Google didn't develop the content, they just helped you find it. Amazon has seen more success than eBay, but similarly, its success is primarily through connecting shoppers to manufacturers. Often Amazon isn't even the seller, but merely facilitates advertising and transactions. Uber connects those who need a ride with drivers. Drivers are treated as independent contractors, while Uber manages the prices and payments and provides a framework for communication and establishing trust. The most successful tech companies' prime services are more about connecting service providers to customers and content to consumers than they are about providing content or services themselves. The reason this is such a successful business model is that it scales so easily, and the funding they receive increases with the scale of their enterprise. As of this writing, Jeff Bezos is worth over $200 billion, and other big tech executives and the companies that they run have seen similar financial rewards. Between 1989 and 2016, including much of the time these companies have developed these products, Pew Research Center indicates that the wealth gap between America's richest and poorer families more than doubled. To the extent that these companies produce software rather than services, university-led FOSS presents an opportunity to produce similar products that reinvest much of these financial resources with the producers and consumers themselves, rather than the big tech middlemen. While public research is often funded through taxes, university expenses need not include massive data mining projects to maximize consumer engagement or lavish executive salaries, and supplementing a more meager financial reward, motivations for research also include recognition, passion for the outcome or even just the process, and the altruistic intent that researchers have when they understand that their work has true civic value. To a large extent, these are costs already incurred by tax and tuition payers for the university systems we already have. The issue is more about what we as academics consider scholarship and the expectations in place for the kinds of scholarship we produce. The success of FOSS in this context does depend on what aspects of these tech companies are being substituted and whether they provide more than just software. For example, no software can provide the whole of the services offered by the shipping infrastructure that Amazon has created. FOSS projects also often compete alongside big tech products similar to UPS and the USPS, and in other cases the projects are directly integrated with or wholly managed by these companies. For example, IBM has seen more success lately working with Linux rather than producing their own operating systems, and Oracle has adopted open source community-driven development principles for Java. In this context, university-led FOSS contributions might look very different from those developed by corporations or other independent groups. Rather than provide an all-in-one service, research should focus on software components that can be integrated into other, possibly commercial, projects, or open and decentralized protocols for communication between applications, similar in spirit to the protocols like those that the World Wide Web is based on. Consider a framework for establishing and verifying a driver's experience based on public key cryptography and social networks rather than a third party like Uber, which even in this regard mostly manages attestations of reliability developed by its users themselves rather than evaluating confidence in drivers directly. Imagine a protocol that allows you to search for sellers and integrates with other third parties to provide services such as payment, shipping, as well as identity, authentication, and trust. Traditionally, software developers seeking employment would burnish their credentials through their employment history and recommendations from supervisors and coworkers. However, employers are increasingly judging applicants' potential through analysis of their contribution to open source projects. This raises the importance of student-faculty FOSS collaborations, both as applied learning activities and as opportunities for portfolio and reputation building for the student. I want to speak a little bit about using free and open source software in the university environment. We have a number of projects ongoing at Missouri Western, many of which are a work in progress, but are exploring some of the boundaries of what we can produce with open source software in an implied learning environment. So, among the projects that students and faculty have been involved with at Missouri Western have been community service projects, such as this website developed by a Missouri Western student for a local organization that assists with managing feral cat populations. Students and faculty have also been involved in developing software for managing processes within the department, particularly our curriculum development efforts and scheduling. Open source projects have obvious utility to teaching programming all across the curriculum. I like to include open source projects early in my courses to show students what it might be like to work on a larger project and to help them apply the skills that they're learning. This example is a Minesweeper, an open source Minesweeper project on GitHub that I have students make small changes to using some of the concepts that they've learned through the first third of the class. Academics involved in open source software development are going to find obvious use cases within the problems that they're dealing with. And in particular, educational software makes a lot of sense for academic open source development. This is a screenshot from some software that I'm developing called Code Cafe, which is intended to help students learn to program, similar to tools available from commercial sources such as Turing's Craft Code Lab. Open source can reach the classroom in other ways than software, such as through open textbooks, which are often released with a Creative Commons license. The University of Minnesota Open Textbook Library has a host of different open textbooks that you can adopt freely in your own classes. You don't need to be in a computer science classroom to get students involved with open source, and not just by using open textbooks. You can use open source software in the classroom to do all sorts of tasks. For example, I'm currently developing this talk on a Linux system using LibreOffice for the slides and to write my scripts, and using OBS Studio and OpenShot, as you can see here, to record and edit my videos. Through this talk, I've outlined the impact that open source software can have and the impact that academia can have on open source software, and I hope that through better support of open source development seen as and supported as scholarship within universities, we can reach better outcomes for the communities that these universities serve. Thank you for your attention.